Hello students, today we are going to summarize the work which had been done within week 3. We will discuss lesson 10.5 volume of composite figures. By the end of this session, you must be able to find volume of composite figures. Number 2, apply volume of composite figures in real life problems. We are going to solve selected exercises from pages 573, 574 in your textbook. We will begin with question 2. Find the volume of each solid round to the nearest 10. And it's very clear here that the figure is consisted of two solids. It is consisted of a cone which is stacked on hemisphere, and stacked or stacked means composite. So a cone and a hemisphere had been composited with each other. To find the volume of this solid, we need to find the volume of each. To find the volume of the composite solid, we need to find the volume of each solid separated. So we will begin step 1 by volume of cone. Volume of cone equals 1/3 pi r squared times h, which is height, and r is given here. The radius of the cone is 4 centimeters. And notice that it's at the same time the volume of hemisphere. And the height of the cone is 10 centimeters. We will go directly and substitute 1/3 as it is, pi keep it, and r squared means 4 squared times height, which is 10. 4 squared equals 16, and we will multiply 1/3 times 16 times 10. We will get 53.33 pi. And we need to round to the nearest 10. So we will look to the digit, which is 10, underline it, and look at the digit to the right of 10. It's a 3, and 3 is less than 5, so we will cancel it. We will keep the 3, which is 10. So the volume of the cone is approximately equal to 53.3 pi cubic centimeter. And step 2, we need to find the volume of the hemisphere. It's very clear here that the volume of hemisphere, the radius of hemisphere is the same as the radius of cone. So r of the hemisphere is 4. Volume of hemisphere equals 2/3 pi r cubed. And here r cubed means repeated multiplication r times r, which is 4 times 4 times 4. 4 times 4 times 4 is 64. So 2/3 pi times 64. We will multiply 2/3 times 64, which is 42.66 pi. We will keep the pi, and we will round to the nearest 10th. The 10th here is 6. Look at the digit to the right. It's 6. 6 is greater than 5. So I'll cancel this and add 1 to the 10th. The volume of hemisphere will be approximately equal to 42.7 pi cubic centimeter. And don't forget that we are trying to find the volume of the solid, the composite solid, which is consisted of cone and hemisphere. We already done. We found volume of cone and volume of hemisphere. So the last step will be step 3, find volume of the composite solid. Composite solid means the solid which is composed of cone plus volume of hemisphere, which is 53.3 pi plus 42.7 pi equal 96 pi, and then we will substitute here finally by pi equal 3.14. We will get 301.44, and for we need to round. The question asked you to round to nearest tenth. We will look to the digit to the right. It's 4 less than 5. We will cancel it and we will keep the 4 as the tenth. So the volume of the composite solid is 301.4 cubic centimeter. And I just want to give you this note. Teacher, why did you keep pi here? Why we didn't substitute by pi equal 3.14 from the beginning? Because if the volume of the two composite solids contains pi already, like volume of hemisphere and cone, volume of sphere and cylinder, two cylinders together, all of these includes pi. It's easier for you to keep pi, to reduce the numbers and calculations, keep pi and substitute by pi equal 3.14 at the last step to make the calculations easier for you. Let's go to other exercise. Let's go to exercise 4. Find the volume of the nail polish bottle round to the nearest 10. Here is this figure represents the nail polish bottle. And this nail polish bottle is composed of two solids. The first solid, which is the base down, it's rectangular prism. This is rectangular prism. And the top is cylinder. And I want to give you a hint how to find the volume, how to figure out, are you going to add or subtract the volume of the given solids or the composite solids together. If the two solids are stacked above each other like this, here is the rectangular prism down and cylinder up. In this case, we will add the two solids together to get the volume of the solid, of the bottle, of the nail polish bottle here. Okay, so volume of rectangular prism equals length times width times height. Here is the length, 28 times 22 millimeter times 22, which is 13,552 cubic millimeter. Cubic millimeter. And we will go to the second step, which is volume of cylinder. Look at the cylinder here. What is given mass? What is given related to the cylinder? The given here is diameter, the full diameter. So I need to find the radius. The diameter is h is 11 millimeter. So r equals diameter divided by 2. Radius equals diameter divided by 2. 11 divided by 2 equals 5.5 millimeter. And now we will go to find the volume of cylinder. The formula of volume of cylinder is pi r squared times h, which is height. And here, because the composite figure includes rectangular prism, which doesn't include pi, we will substitute here, no need to keep the pi in volume of cylinder. We will substitute by pi equal 3.14 directly from the first step, because there is no other pi in volume of rectangular prism to add it together. So volume of cylinder equal 3.14 times 5.5 times 18, which is 1,709.6 0.73 cubic millimeter. And again, let's back to the figure. The figure here is nail polish bottle, which is consisted of rectangular prism and cylinder. We already found the volume of both, and the cylinder is stacked above the rectangular prism. So we will add both volumes together. So volume of the nail polish equals volume of rectangular prism plus volume of cylinder, which is 13,552 plus 1,709.73 equals 15,261.73, and we need to round to the nearest tenth. Here is the tenth. Look at the digit to the right. It's a 3. 3 less than 5. I'll cancel it and I keep 7 in the tenth. So the volume of the nail polish bottle is 15,261.7 cubic millimeter. Let's go to other question, exercise 3. Find the volume of the flower vase round to the nearest tenth. Look at the figure here. It's very clear that these two solids, one is composed inside the other. So this will not be plus, it's not above. How will we solve this? We will follow the same steps. We will find the volume of both solids, but in this case, we will subtract because the cone here is inside the rectangular prism. Let's figure out how will we solve it. Step 1, we will find the volume of rectangular prism, which is length times width times height. 20 times 10 times 12 equals 2,400 cubic centimeter. And then step 2, look inside. What is inside? Which solid is inside its cone? So we need to find the volume of this cone. What is given related to the cone? The diameter is given. So we need to find R, the radius. R equals D divided by 2 equals 4 centimeters. And we will substitute in the formula of volume of cone. Volume of cone equal 1 over 3 pi R squared times H. So it will be 1 over 3, and we will substitute by pi equal 3.14 times 4 squared, which is 16 times 12. Equals 200.96 cubic centimeter. And let's go to step 3, which is volume of the flower vase. Volume of the flower vase here represents the difference between the volume of the rectangular prism and the volume of cone, which is subtraction. So volume of the vase equals volume of the rectangular prism, which is 2,400, minus volume of the cone, 200.96, equals 2,199.04, and we need to round to the nearest tenth. The tenth here is 0, digit to the right is 4, 4 is less than 5, so we'll cancel 4, and the volume will be approximately equal to 2,199 cubic centimeter. Let's go to exercise 6. Find the volume of the solid, round to the nearest tenth. And find volume of the solid means find the volume of the solid which is given. And this solid which is given is composed of cylinder and hemisphere inside it. And because the hemisphere is inside the cylinder, In this case, we will find volume of cylinder, volume of hemisphere, and then subtract volume of cylinder minus volume of hemisphere to find the volume of the solid which is contained between these two solids. Volume of hemisphere depends on the radius, and the radius of hemisphere here is this part. Only this 5 centimeter is volume of hemisphere. So let's write the formula down. 2 over 3 pi r cubed equals 2 over 3 pi times 5 cubed. 5 cubed is 5 times 5 times 5. Repeated multiplication equals 125. And then we will multiply 2 times 125, which is 250 over 3 pi. Teacher, why did we keep the pi here and we didn't substitute by 3.14? Because we have hemisphere, which includes pi in its volume, and also cylinder, which includes pi in its volume. So we can keep pi until the final answer to reduce the numbers and calculations. Volume of hemisphere will be 250 over 3 pi cubic centimeter, and we will go to find the volume of cylinder, the outer solid. And what is given here related to cylinder? The given here related to cylinder is its height, which is 16 centimeter, and its radius, which is this length, 5 centimeter plus 5 centimeter. So radius of cylinder equals 5 plus 5 equals 10 centimeters. Let's substitute in the formula. Volume of cylinder equal pi r squared times h. R squared here, r is 10, h is 16, and 10 squared is 10 times 10, which is 100. So I'll multiply 100 times 16, 1,600 pi cubic centimeter. This is the volume of the cylinder. And the question asks you about the volume of the solid, which is the composite, the volume of the whole composite figure. It means the volume of cylinder minus volume of hemisphere. Because hemisphere is inside the cylinder, we will subtract. Volume of the composite solid equals volume of cylinder minus volume of hemisphere. 1,600 pi minus 250 pi over 3, 250 over 3 pi. It will be 4,550 over 3 pi. And in this step, teacher, I'll substitute by pi equal 3.14. So the volume of the composite solid will be 4,762.33, and we need to round to the nearest 10. So we will underline the 10. Look at the digit to the right. It's 3 less than 5. I'll cancel it and I'll keep the 3, which is the 10. The volume of the composite figure, the whole figure here is the volume of the composite figure will be approximately equal to 4,762.3 cubic centimeter. And we will go to one more exercise. This is multi-step real life exercise. It's about how to apply your understanding of volume of composite figures in multi-step real life problems. Mel's ice cream shop has a cylindrical container to hold its ice cream. Each cylinder has diameter 10 inches and height 15 inches. How many of the cones shown can be made without any leftover ice cream? I read it again. Mel's ice cream shop has cylindrical container. Is the cylindrical container here in the figure? No, teacher. The cylindrical container is not here. I want to show this part. Mel has an ice cream shop, and this ice cream, he keeps the ice cream in a cylindrical container. Here it is. This is the container. This is not shown in the exercise. This you have to draw it in your brain or on your copybook down. And Mel's ice cream shop has cylindrical containers to hold its ice cream in. Each cylinder has a diameter of 10 inches and height 15 inches. So the diameter of this container is 15 inches and its height is 10 inches. How many of the cones shown, do you see this cone? How many of the cones shown can be made without any leftover? So whatever ice cream inside this container, we want to, or Mel wants to make ice cream cones. Ice cream cones, we don't know how many. Using the ice cream which is inside the container. Did you get it now? So we need to find the volume of all of the ice cream inside the container, and when we find the volume of all of the ice cream which inside the container, we will divide it into small ice cream cones. Okay, now let's go to the steps. Step 1, we will find the volume of the cylindrical container, and the given for the cylindrical container is the diameter, which is 15 inches here. So we need to find R. R equals D divided by 2, which is 10. Which is 10. I mixed the diameter with height. Not a big deal. I'll rearrange it. Here is the diameter, which is 10, and here is the height, which is 15. So the radius will be diameter divided by 2. Diameter divided by 2, which is 10 divided by 2, equal 5 inches. We'll find the volume of cylinder, substitute by the formula pi times r squared times h. R is 5, it will be 5 squared, which is 5 times 5, 25, times 15, it will be 375 pi. So volume of the whole ice cream inside the cylindrical container is 375 pi. This is the volume of all of this ice cream inside this cylindrical container. Okay, and now we need to find the volume of one cone of ice cream, which is shown here. What is given related to the ice cream cone? The diameter of the ice cream cone, which is consisted of two composite solids. It contains a cylinder, it contains a cone and hemisphere. It is hemisphere stacked on a cone. And the hemisphere and the cone, both of them share the same diameter, which is 3. So we need to find the radius for the ice cream cone, which is at the same time the radius of the hemisphere also. It will be d divided by 2 equals 1.5 inch. So we can here, because we already solved many real life problems, we can find the volume of the ice cream cone in one step. Because now we can work more than one formula in the same step. Volume of the ice cream equal volume of the cone plus volume of the hemisphere. And we will substitute by both formulas in the same line, because now we solved a lot of exercises. So it will be 1/3 pi r squared times h, which is volume of cone, plus 2/3 pi r cubed, which is volume of hemisphere. We will substitute just by r here, r squared, which is 1.5 squared, and h, which is 4, plus r cubed. It's the same radius we said. It will be 1.5 cubed. And then when we solve, we will get for volume of cone equal 3 pi and volume of hemisphere equal 2.25 pi. And now we need to find the total volume of the ice cream cone, the whole volume of this ice cream cone equals 3 pi plus 2.25 pi equal 5.25 pi. And step 3 now, we need to go to this figure again. Now we know the volume of all of the ice cream in this ice cream container, which is 375 pi. This is the whole volume of all of the ice cream. And the volume of one ice cream cone, which is volume of one cone from these equals 5.25 pi. And now we need to know, when I divide 375 pi by 5.25 pi, how many cones of ice cream will Mr. Mel get? And the question asks you at the beginning with no leftover. So number of ice cream cones which can be made without any leftover equals 375 pi divided by 2. 375 pi divided by 5.25 pi equals 71 cones of ice cream without any leftover in the cylindrical container. That's it. I hope that you got the idea of how to find volume of composite figures and how to apply it in real life problems. Now you're supposed to go to your book and resolve the whole exercises. Good luck. Thank you very much.